we are going to be talking about graphs of other functions. We just did sine and cosine so far, and now we're going to do all of the others. So tangent, cotangent, secant, cosecant. So we're going to start off with tangent. All right, so let's remember what tangent of x is, right? Tangent of x is sine x over cosine x. Now, immediately what we see is we have a rational function here. We have something where there is a variable in the denominator. We know that when we have a variable in the denominator, there is a potential of the denominator being 0, which is undefined, right? So we know that tangent of x is going to be undefined whenever the denominator is 0. The denominator is cosine x. So wherever cosine x is 0, the function is going to be undefined, and the graph of f of x will have vertical asymptotes. So if we think about where is cosine of x equal to 0, well, it's at x equals pi over 2, 3 pi over 2, 5 pi over 2, and so on, right? But also not just positive pi over 2, but negative, and not just positive 3 pi over 2, but negative, and the same with this. So at all of the pi over 2's, this is undefined, and there is a vertical asymptote, right? So that tells us, right, if our angle can't be any of the pi over 2's, that tells us that the domain can never be all real numbers, right? So the domain is not all real numbers. However, remember what we talked about on the very, very first day of this lesson? We said sine and cosine are one of the legs over the hypotenuse, so they're always going to be less than 1. But tangent compares the lengths of the two legs, right? Opposite over adjacent. So was there a restriction on whether tangent can be less than 1, greater than 1, equal to 1? No, tangent could take on any value, right? Which again tells us that the range of the tangent could always be all real numbers, right? But the domain cannot be. So now, if we think in terms of period of a tangent, remember the period is the interval in which one cycle will complete. One cycle for the tangent, if you look here, it's these arms, right? Each one of these arms is one cycle of the tangent. So you see here, each cycle, like this first cycle, goes from negative pi over 2 to pi over 2, right? So the period is just pi, not 2 pi. Yes? That means when we're looking for the period, we're not going to do 2 pi over b anymore. We're going to do pi over b now. So that's how we do this. Now, so this is how each of these look. All right. The general form of the tangent function looks like this. You see it's similar, right? You have the a, b, c, d, just as you did with the other functions. And when you have this, you can find the vertical asymptotes at the negative and positive pi over 2's. Always. Okay. Now, so let's take a look at some problems here. So the period of the tangent function we said is pi. So we're going to find it by doing pi over b, not 2 pi over b. Okay, take a look here. Because of that, when we set up our graphing or inequality for the graphing region, we're not going to go from 0 to 2 pi anymore. For tangent, we're going to go from negative pi over 2 to pi over 2. Again, bx plus c in the middle. That's why I spent a whole period on sine and cosine, because the process we learned there is going to carry over to all the other functions as well. Right. So let's take a look at this. We have to graph the tangent of 3x. Now, a is 1 here, and this is b. b is 3. So the period is pi over b, which is pi over 3. Right. To find the asymptotes, we're going to first write the inequality like this. And inside, we put 3x. So very similar to what we were doing before. Now, I'm going to divide by 3, which is the same as multiplying by 1 over 3. So I get negative pi over 6, x, pi over 6. Now, just like before, negative and positive pi over 6, this gives us the graphing region. But in the case of the tangent, this also gives us the asymptotes, right? So this is how we solve for the asymptote. So both of these are the vertical asymptotes. So over here, I say x is plus or minus pi over 6. Okay, so let's graph this. For these, I'm going to keep my tick marks like close to each other. So here we have negative pi over 6, 1, 2, 3, 4, pi over 6. Do you see how it's still the same? Nothing has changed from what we were doing before. The point in the middle is 0. How much is the quarter point at the left here? Negative pi over what? 12 and positive pi over 12. Okay, so here I'm going to put the asymptotes. Okay. For our first one, I'm going to graph using a table. So here I have x and I have y. All right, so for x, first I'm going to put in 0. I'm going to go in the middle here. I'm going to put in 0. So this is going to be tangent 3 times 0, which is tangent of 0, which is how much? 0. Okay. And you're going to have that every time. That center point is going to correspond to tangent of 0, and it's going to be on the axis every time. Now, let's go to pi over 12. This is going to be tangent of 3 pi over 12, which is how much? Tangent of pi over 4, which is what? 1. So here, I go up to 1. Okay, the last one, negative pi over 12, is tangent of negative 3 pi over 12. Tangent of negative pi over 4, how much is that? Negative 1 right there. Okay? So now, when I graph this, it's got to follow the vertical asymptote to the left at the top. To the right, it has to follow the vertical asymptote at the top. To the left, it has to follow the vertical asymptote to the bottom. So there is really one way for us to graph this, and that is this. Okay? Now, there is none of this business. Okay? That's not a tangent graph. That's a waterfall. This is not a tangent graph, right? So just this. Okay? All right. Questions? All right. Let's take a look at this one. So period, pi over a third, which is 3 pi. Asymptotes. So we're going to go from negative pi over 2, 1 over 3x to pi over 2. Multiply everything by 3. So what do we get now? Negative 3 pi over 2, x 3 pi over 2. Okay, so the asymptotes are, you can either say plus or minus 3 pi over 2, or you can say negative 3 pi over 2, x equals 3 pi over 2. If you don't have x equals written there, if it's just 3 pi over 2, that's not full credit.
Is there anything to say x equals on the sine and cosine functions?
No, these are for asymptotes. Okay. Okay, so now, negative 3 pi over 2, positive 3 pi over 2. So let's go here. Oh, guys, I didn't put the y-axis here. Okay. All right, so negative 3 pi over 2. 1, 2, 3, 4, 3 pi over 2. 0. So here I get 3 pi over 4, negative 3 pi over 4. Asymptote. Asymptote. Okay, 0 is again gonna hit 0. Right? It's on the axis. 3 pi over 4, it's like magic. If you put 3 pi over 4 for x, what do you get? What's 1/3 times 3 pi over 4? Pi over 4, right? So again, you get it to correspond to tangent of pi over 4, which is going to be 1. So to the right, I need to go up 1. But now, how high up do I go? 2. I go up 2. To the left, I go down 2. Now, imagine if you held on to either end of this graph and you just stretched it, right? What would it look like? Just, yeah, less curvy, right? Again, so just make it less curvy. Students somehow add more curves to this, right? Don't do that. Just, grab your hand and just go like up, down. Okay? All right. So let's talk about a reflection around the x-axis. All right. So here I have negative tangent x over 4. The period is going to be how much? Pi over 1 over 4, which is 4 pi. Okay. Asymptotes. Negative pi over 2 to pi over 2. What goes in the middle? X over 4. So negative 2 pi to 2 pi. Oh my God, I keep forgetting the y-axis. How come this always happens to me? Okay. So negative 2 pi to 2 pi. Zero, negative pi, and pi. Okay. Center point goes where? 0. And remember, there are asymptotes. Okay, this time there is a reflection. So to the right, where do I go? Down 1. To the left, I go up 1. And then everything else is the same. So the asymptotes are x equals plus or minus 2 pi. Right? And again, what's the difference? What's the distance from negative 2 pi to 2 pi? 4 pi, which is what? The period. Right? Okay. All right. Ooh, take a look at this one. We got a little bit of phase shift, right? Okay. So phase shift. What's the period of that one be?
Pi over 2?
Just pi.
Oh.
Right? Because this is 1, so it's just pi. Okay. Phase shift is the same as we did before. So x plus pi over 2 equal to 0. X is negative pi over 2. Okay, so let's do the inequality. Negative pi over 2. It's nice too. To pi over 2. And here we put x plus pi over 2. So minus pi over 2 minus pi over 2. On the left side, how much do I have? Negative pi, and then here's 0.
But why do you have negative pi over this?
Because it's negative pi over 2 minus pi over 2.
Oh.
So here, negative pi, 1, 2, 3, 4, 0. Okay, and okay, I don't know what it is with me and tangent graphs, but I always forget the y-axis. I don't know, it's so weird. Okay. Here, the middle is negative pi over 2. Then this is negative pi over 4. Negative 3 pi over 4. Okay, you know what? For this one, why don't we put the y-axis first before we put the asymptotes? Because they're going to correspond. I don't care. Okay. Right, so this is the y-axis. Now, the asymptotes, right? One goes here. The other one is on top of the y-axis. So we're going to put it there. You know, you can put it like a hairline to the left or right so that it's just like visible, right? Okay, now center is on the axis. And then to the right, am I going to go up or down one? Down. Here, up. Right here. And then the asymptotes are x equals negative pi, x equals 0. Okay. So we should have gone from negative pi over 2 to pi over 2, right? The phase shift is to the left, pi over 2. So instead of starting at negative pi over 2, we started that much over at negative pi. Yeah, we would have, it was supposed to be here. This is half a pi distance, we went that way. The y-axis is here on the 0.
It's always on the 0 even.
Yeah, yeah.
Is the fucking y with negative 10 stuff fucking same as y with negative?
No, because they're different. They're different.
Is it okay that I just censored it? Or like,
Oh yeah. I should have just chosen better. No. Like this one I centered it, but that one yeah. Okay, let's move on to the cotangent. Very similar, except cotangent is the reciprocal. So it's cosine over sine. That means it's undefined when sine of x equals 0. That's when there are vertical asymptotes. So it's at x equals 0, plus or minus pi, plus or minus 2 pi, and so on. So take a look here. This is what cotangent looks like. Again, the range is all real numbers, but the domain is not. Now, the period, again, right, so okay, here there's supposed to be another asymptote, right? The period again is pi. So let's compare tangent and cotangent. Tangent goes from 0 to pi. And do you see how it's oriented differently? It's going down to the right instead of going up to the left. Okay, and you know what? Let's look at that a little bit more closely. Let's go over here. So if you can see, they're shifted, right? This is from negative pi over 2 to pi over 2. The other one is from 0 to pi. They're shifted. They're different locations. Now, let's think about this for a minute. Look at this region, 0 to pi over 2, right? On the unit circle, Which quadrant does that correspond to? Quadrant 1. And in quadrant 1, is tangent positive or negative? Positive. That's why over here it has to be positive, because you're literally in the positive quadrant. This one, however, here, from negative pi over 2 to 0, what quadrant is that? You're sure? From negative pi over 2 to 0. Where's negative pi over 2? This is negative pi over 2. Negative pi over 2 to 0 is there. In that quadrant, is tangent positive or negative? Negative. That's why tangent has to be positive over here. It has to be negative over there, because the left corresponds to quadrant 4, the right corresponds to quadrant 1. Now let's go to cotangent. Cotangent is in a different spot. So when I look at this portion, pi over 2 to pi, which quadrant is that? Quadrant 2. Is cotangent positive or negative there? In quadrant 2. Negative. That's why it's below in the negatives, right? Here, 0 to pi over 2. What quadrant does that correspond to? The first one, 0 to pi over 2, right? Is cotangent positive or negative there? Positive. That's why it's up here. Do you guys see that? So they're not just a reflection of each other. It's literally like trigonometry. That's why they're the way they are. Okay. So okay. So now for cotangent, it's not 0 to 2 pi. It's not negative pi over 2 to pi over 2. It's 0 to pi, because that's where the default period, like cycle is. Okay, so here we go. For this one, b is 2. So period is pi over b, pi over 2. Okay, for the asymptotes, we're going to go 0 to 2 pi. To pi. And we put 2x in the middle. Now, divide everything by 2. So I go to 0, from 0 to pi over 2. So my asymptotes are 0, x equals 0, x equals pi over 2. Okay. And I'm going to center it for Lily. Okay. Here we go. This is pi over 4, pi over 8. And what's the other one? 3 pi over 8. So 2 ways to do that. Either add these and divide by 2. Or, look, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, right? So 3 pi over 8. Okay. Y-axis goes here, but also asymptote goes here. Make sure it's visible. Okay. Now, center on the axis. When is the center point not going to be on the axis? With a vertical shift. If there is a vertical shift, everything like shifts. Okay? So now, to the right at 3 pi over 8, do I go up 1 or down 1? Down 1. And then up 1 here. Oh my God, I just love this stuff. Don't you all love this stuff? Like, so cool. Cotangent. Look at that. Yay. Yay. Slay. Is that still a thing? Not so much. So what is it now? No? No, nothing took its place? Just say cool? No. Okay, no. No. Okay, Let's go to secant, cosecant. Ready? Secant, cosecant. More reciprocal functions. Yay. Okay. What? Well, you know. Okay, let me. Cosecant and secant, these are reciprocal functions, right? So cosecant is 1 over sine. Secant, 1 over cosine. Same situation. Whenever the denominator is 0, we have asymptotes. Similarly, in addition to that, the cosecant has minima where sine has maxima and vice versa. So let's take a look at the cosecant graph for a minute. Look at this one here. Do you look at the dashed graph? What is that a graph of? Sine x. That's the regular old sine x we've been graphing for like a year now, right? Now, do you see how sine x hits the x-axis at regular intervals? Periodically, haha, right? Okay, so at each of those places where sine hits the y-axis, cosecant has asymptotes. There's also one here. I don't understand why the book thinks it doesn't have to draw asymptotes on the axis, right? Now, so here's how we're going to graph these. We draw a sine graph. Easy. We draw vertical asymptotes wherever the sine graph hits the x-axis. Then, at each of the maxima for the sine, cosecant has a maximum, and it looks like a parabola, but it's not. It's literally an inverted sine, right? And then at each of the minima, cosecant has a maximum. Again, you take this part of it here, and you invert it there, okay? So now, let's think about range for a minute. Sine, right? Sine values always go between -1 and 1, correct? Yes. Here. Cosecant, right? So sine of x is usually less than 1, but cosecant of x is greater than 1 or less than -1. So cosecant takes on the other value that's greater than 1 or less than -1. Okay? Secant is the same thing but with a cosine. So take a look here. This dashed one is the cosine, right? Wherever the cosine hits the x-axis, we have vertical asymptotes. Then again, inverted cosine here, inverted cosine here, and so on. Now, if you look at only the graph of secant and cosecant, this is what it looks like, right? So right here, do you see how for the range, there is empty space here, and then it's either above or it's below. So look at how we write the range. The range is either from -infinity to -1 and 1 to 0. Okay? I'm sorry, 1 to infinity. Okay. Period is also 2 pi because it's like sine and cosine. Okay, so let's graph a couple. And then I'm not going to have you do any extra math for the asymptotes. You're literally just going to pick them out of the graph. Okay? So here, we need to graph 2 cosecant 2x. Now, this is the reciprocal of the sine. So first I graph y equals 2 sine 2x. That's this. I know we know how to graph this, so I just did it with my computer. Usually we would only graph from 0 to pi, 1 period. I just went ahead and told the computer to do it twice just so we get a little bit more practice. Now, you draw your sine graph. Then, this part has no math involved at all. You literally just draw vertical asymptotes wherever this hits the x-axis.
Why is there an asymptote where it hits the x-axis?
Because where sine hits the x-axis, 1 over sine, if sine is 0 there, 1 over sign will be undefined. Yeah? Of course it makes sense. It's math, right? So I'll tell you. Let's graph. Okay, actually, let's fill this in first. So the period is going to be 2 pi over 2, which is pi. And then for the asymptotes, literally just look at the locations and write them. So I'm going to, save myself some ink here. There is an asymptote at x equals 0, comma. Then there is one at pi over 2 and negative pi over 2. So x equals plus or minus pi over 2. X equals plus or minus pi. Sure. X equals. Always x equals. Yeah. Now listen. Only list the asymptotes that are visible on your graph. You don't have to go extra. Now, for the actual graphs then, you see how for this one there is a maximum there? You want to make sure that your cosecant coincides with that point. It hits that point. So I go here and I follow the asymptote, and same thing here. Don't touch the asymptote, just follow it. Okay? Cool? Isn't that fun? And that's a good enough graph for me. So now let's do, let me do secant and you'll know exactly. So let's do secant. Okay, let's do this one. Negative secant 2x. So first, I'm going to graph y equals negative cosine 2x. Let me finish this and then I'll take that question. So this is going to go from 0 to pi over 2. Is that right? Oh yeah, because no. Oh my god, this is 2 pi, so that's just pi. Okay, so here we go. I'm purposely gonna, okay, so here's what I'm gonna do. I'm gonna start here, but I'm going to draw a condensed one here. 1, 2, 3, 4 to pi. I'm purposely not skipping boxes this time. Pi over 2, pi over 4, 3 pi over 4. Okay, now I need to graph a negative cosine, right? So that goes from here, from negative 1, 0, 1, 0, negative 1. Okay, now asymptote here, asymptote here. So in the middle, okay, that's obvious. I do this. Now, you either have to go to the left or to the right of this. Let's go to the right. If I draw this, that's not a complete inverted cosine, right? That means I have to, either on the left or on the right, I have to complete this. So I have to go one additional point. So why don't we go to one additional point here? What would that value be? 5 pi over 4. So I connect another asymptote and I can do this. Now it's complete. Now it's a complete cycle. So for my period, for my asymptotes, I'm going to say x equals pi over 4, x equals 3 pi over 4, and 5 pi over 4. Do you see how it needs to be done? So now, here's the other question. Do you have to draw the sine or cosine when you're doing the secant or cosecant? Technically, no. We only do it to help us and to guide us. If you can do this without having that, fine. Okay? But then, this just helps you. Huh? You don't have to label anything. I mean, I know. This is, if you draw me this, I'll know. Okay, and this is where we end. Perfect time.